This video is to summarize investigation 2C. So in this investigation, you construct both mathematical and non-mathematical arguments, and as you move toward reading and writing more formal proofs, you learn there are many correct ways to prove the same facts. And there are also many ways to present the proof, and the working proof may look different from the final proof. And because there are so many proofs for you to work through in this investigation, it took a little longer for us to go through everything. So we have learned what the proof is. We have learned four different types of proof, which is two-column statement reason proof, paragraph proof, outlined style proof. Many people preferred in our classes. Many people prefer the ways that is taught in China very commonly, or the one that is studied in Russia as well. And we used 3 dots, looks equilateral, to say therefore or thus. And we used backwards 3 points to say because or given. And we analyzed the statements, statement to proof. We have learned how we can find hypothesis and conclusion. We have looked at if-then form. So the sentence comes after if is the hypothesis, and sentence comes after then a conclusion. And if a sentence is not written in if-then form, then we know that we can separate any sentence into 2. And the subject of the sentence is the hypothesis, and the predicate of the sentence is the conclusion. For example, if it says 2 triangles with the same area are congruent. So this is just one simple statement which is not written in if-then form. However, we can break that into 2 sentences. First, 2 angles have the same area. Second, the 2 triangles are congruent. And the first one is the hypothesis, and the second one is the conclusion. And we have learned 3 different ways to analyze a proof. One is the visual scan, using the tick mark, like that, or we use the parallel lines so that we can see it. Also, we have learned the flow charts. We started out with the given and then put the items in the box so that we can see the flow. Or sometimes there is other things comes in, and then I go to the conclusion. And also we spend a lot of time going through the reverse list. We started out with the conclusion instead of a hypothesis, and we looked at what's needed and what we can use. We have learned that in lesson 2.13. So instead of starting from given, and we started out with proof and think about what we need in order to do that. And then after we got some good idea, we started writing proof. So lesson 2.13, we went through some problems such as TUVW is a rectangle. And then x is the midpoint of TU, and prove that triangle XVW is isosceles triangle. So we did so first we started out with the conclusion. So we wanted to have WX is congruent to VX, segment VX. In order for us to do this, we first have to prove triangle TWX is congruent to triangle UVX, so that we can say, if we prove these two triangles are congruent, then we can say segment WX is congruent to segment VX by CPC2C. But in order for us to say these two triangles are congruent, we have to use something, triangle congruence postulate. And we use the visual scan. We can combine that. So we know that TX is XU because it's a midpoint. And we also say VU is congruent to WX because of the rectangle. And we also say angle U and angle T are 90 degrees, therefore it's congruent because TUVW is a rectangle. So we can use by SAS. We have to say what the S is, which is TX. Segment TX is congruent to segment XU because X is a midpoint, or you can just simply say definition of midpoint. So that's first S, and A is angle, we should say measurement angle, T equals measurement angle U, which equals 90 degrees. That's because of definition of rectangle. I'm using abbreviation here, but if it's a formal proof, you gotta write it out. Anyways, we also say segment VU is congruent to segment WT, which is also a definition of rectangle. And what is given here, we can say this is given. I mean, this is given because it's rectangle, and also this is given as well. And then we can start writing the real proof by using this reverse list. So that's what we have learned in 2.13, and we practiced writing proof. And as we go through, we have proved that isosceles triangle theorem. So the isosceles triangle theorem says if we have isosceles triangle, then the angles are congruent. So the proof was that we know that these two triangles has to be less than 90 degrees as well, because, not as well, these two angles has to be, each of them has to be 90 degrees, because if these two angles, each of these two angles are 90 degrees, then 90 degrees plus 90 degrees plus some degrees, then it has to be more than 180 degrees, which contradicts the triangle angle sum theorem. So let's say angle B and angle C, measurement angle B and measurement angle C has to be less than 90 degrees. that tells us that the altitude has to be entirely inside of this triangle. Okay? And this triangle divides this isosceles triangle into two triangles, which we call, let's say, ADB and ACD. Now we can use the fact that segment AB is congruent to segment AC, and also segment AD is congruent to segment AD. And we also know that these are midpoints because the distance between BA and CA are exactly the same, so we can use the perpendicular bisector theorem, which tells us that if we have a point that is perpendicular to BC or any segment, that will be perpendicular if we have the same points. That if the BA is congruent to CA, if the distance between one end point of a segment to the point and the other end point to the same point are exactly the same, then the line passing through is a perpendicular bisector, so it's bisecting. So also we can say BD is congruent to DC, therefore triangle ABD and ACD are congruent by SSS. Once we prove these triangles are congruent, then we can say angle B and angle C are corresponding parts of two congruent triangles, therefore angle B and angle C are congruent. So that's the isosceles triangle theorem. And we also proved that the converse of them, which is if angle B and angle C are congruent, then segment AB and segment AC are congruent. And that's what we have learned in